So what if that argument inside the sine of the cosine is different? So we got a 5x and a 2x. So, well, first thing you got to identify is which one of these is the problem. See, we want to avoid 0 over 0, so if we plug in 0 here, let's see what we get. On the bottom, we get 0 times cosine of 0. Cosine of 2 times 0 is 1. So when you plug in 0 here, we get the cosine of 0, and the cosine of 0 is 1. And on the top, when you plug in 0, the sine of 5 times x, or 5 times 0, is 0. So 4 times 0. So this is 0 over 0. So that is not a determinate form. So as we go forward, keep in mind here, this 1 is not a problem. The cosine of 2x is not a problem. We don't need to worry about that. What we need to get rid of, the problem we need to fix is this x and this sine of 5x. Those were where the zeros came from. So let's work with this. We got the limit as x goes to 0. And so we've got this 4. That wasn't a problem. We got this cosine of 2x. I'm just going to kind of split those off. We're going to break this into some fractions. We got the sine of 5x. That was kind of a problem. And we've got the x on the bottom. All right, so there's everything broken up. Now, I wish I had a 5x down here. Well, we can get a 5x down there if I multiply this by 5x on the bottom, but we can't change the value of it, so we got to multiply by a special form of 1. Now, if I wanted to rewrite this, I could rearrange it like this, because this is all being multiplied, right? Our factors on the bottom are these guys. Still have all of those. The 1 disappeared because multiplying by 1 doesn't matter, okay? This is all multiplication. Technically, these are all in the limit there. So I think we can work with this because this is what we did in a previous example. These are identical. So since we've got 5x and 5x, this is like the sine of theta over theta. And so that's going to 1. If we plug in 0 here, we get the cosine of 2 times 0, which is cosine of 0, which is 1. And we get a 4 on top. And these guys are going to cancel. So that's going to be a 5. And so that's it. 4 times 1 times 5 is 20. That is our limit. Okay, so moral of the story is this. We would like a matching 5x. This is not a problem. Don't get worried about that because it didn't become 0. And we just bring in the factors we need by multiplying by a special form of 1 here. All right. So here we got a bunch of things that are not sines and cosines. Again, we just want to change them into sines and cosines. So, and we should, before we jump too far, test it out. If you plug in 0, that's the cosecant of 0, 25 times 0, which is 0. And that's 1 over the sine of 0. Sine of 0 is 0, so this whole thing becomes 0. Cotangent of 0, if you plug 0 in there, cotangent is 0. So this is an indeterminate form of 0 over 0. So we're going to change these into sines and cosines. This is 1 over the sine of 25x. And remember cotangent? Well, tangent is sine over cosine. So cotangent is cosine over sine of 11x. So first step, we need these to be all in the terms of sine and cosine. Now we need to rearrange this. Let's multiply. Let me think of it this way. We're going to multiply by the reciprocal, or really just multiplying by sine of 25x on top and sine of 25x on bottom because of that 1. So, and when we do that, we end up with something like this. All right. And which ones are the problems here? Well, the sine 11x is a problem because when you plug in 0, the sine of 0 is 0. When you plug in 0 here, the sine of 25x is sine of 0, which is 0. When we substitute 0 here, that's just 1. The cosine of 11 times 0 is 1. So the cosine is not a problem. Don't worry about the cosine. But what we're going to do is we're going to break this up. I'm just going to leave the non-problem cosine out there. And I've got 1 over sine of 11x. And we've got sine of 25x. Now, I wish that this thing matched this. I wish that this was 11x and this was 11x, because then that would match our identity or our limit definition that we know. So I need an 11x on top. This is all multiplying. So I'm going to multiply by 11x on top, but if I multiply the top by 11x, I'm going to multiply the bottom. Also, I wish I had 25x here, because that would be a match. Okay. Well, let's put a 25x down here. I need a 25x on the bottom. But what you do at the bottom, you got to have on the top. 25x. All right? Now, if we rearrange these, which this is a step we normally don't need to write, because just the fact that we have these parts is good enough, but I'll do that real quick. So just moving these things around, we put this 11x over here. So now it's 1 over 11x. We're going to move this 25x over here. So now it's 25x over 1. And now we can find the limit of each of these parts. So when we plug in 0, the cosine of 11x is 1 over 1. This whole fraction goes to 1 because these match. They have to match. And so that's going to 1. And this whole fraction is going to 1. And what's going on here? Well, these x's cancel, and so we're left with 25 over 11. And so that's just 25 over 11. And we're done. Okay? So that's how it works. We need to change things so that they are written in the form of sine and cosine. And then we need to see if we can use these limits to evaluate those special cases. All right, now you got a lot of tools for finding limits, including these special ones here for trigonometry. So we can tackle derivatives soon here, which will be using these limits.